So now we'll finally introduce our protagonist, which is the lithium-ion battery. So there are hundreds of battery technologies. So we first looked at energy, then we looked at energy storage, and then within energy storage, we looked at batteries. Now within batteries, there are a lot of different technologies as well. So what makes lithium-ion batteries interesting? So now let's go back and remember our demands. We want to put back energy as fast as possible. We want to take energy out as fast as possible. We want to put in as much energy as we want. We want to get back most of the energy, and we want to do this for the longest duration of time, cheaply, safely, and while saving space. So let's compare the battery technologies that are out there. So lead acid batteries are the kind of batteries you have in your typical uh, internal combustion engine vehicles, where you have to put, I think if you remember, you have to put water inside a battery. Those are the kinds of batteries. But these days you have more advanced lead acid batteries, and you have a bunch of other kinds of batteries. You have batteries inside your cell phones which are not rechargeable. You can just use them once. Uh, so this is just a good comparison. So if you look at lithium-ion batteries over here, you'll find that it occupies a very good sweet spot wherein it is good at a bunch of different stuff. Very good at some, but above average at a lot of others. So what do these terms mean? There's a lot of jargon over here. So we'll simplify it. Energy density and power density. Density means in the same amount of weight and or in the same amount of volume, the amount of energy that can be stored is larger. And similarly, power density means uh, the amount of current you can draw quickly. Uh, it doesn't require a very huge battery for you to draw a lot of energy out very quickly. So what this means is that lithium-ion batteries can be small, and what that means is that uh, once you shrink the size, a lot of new avenues of applications open up. For example, using your cell phone. The other interesting thing is that the nominal voltage is high, or the power density is high. What does that mean? That means that you can these batteries are relatively high power batteries, and what this means is that you can draw a lot of current, a lot of energy out of these batteries compared to a lot of energy out of these batteries very quickly compared to other sorts of batteries. And these batteries also have a decent life cycle, although not comparable to a few other batteries, but it's getting there. It's increasing as we talk, because there's a lot of research going into it, which means these batteries can last for a very, very long time, and you can cycle them again and again and again. Uh, so, and additionally, something that's not captured in the graph are these batteries are highly efficient. What does that mean? So the amount of energy you put in and the amount of energy you get back almost as much energy as you had put in. Typical efficiencies for lithium-ion batteries can be 90% plus, while for lead acid batteries that number is around 80%. So if you put in X amount of energy, you only get 80% of that back, which is not a very good deal for for lead acid batteries. While lithium-ion batteries, you get 90%, you get 95%, and you get almost all the charge back, which is a pretty big deal. There's something that is not present in a lot of other battery technologies. So what's so special about lithium? Why do lithium-ion batteries perform so well compared to these other kinds of batteries? A couple of reasons. Lithium is the lightest metal, which means it has a very high specific energy, which means, or you would say, it can store a lot more charge in a very small amount of mass, a lot more energy in a small amount of mass. The other thing is it has a very low standard potential, which means it has a high tendency to lose an electron and become an ion, which essentially means it gives a higher voltage compared to other kinds of uh, elements or metals that we might use in batteries. Now let's talk more about lithium-ion batteries. Okay, so let's talk about lithium-ion batteries now. Yeah, so and before we move forward, let's talk about the terminology first. So there are a lot of different terms floating around. You would have heard of cells, you would have heard of modules, you would have heard of battery packs. So I don't want to confuse everyone, so I'll just specify what these things mean. Uh, they have a general technical meaning in the industry. So cells are the building blocks. These are cells are these small things, cylindrical. Uh, this is called prismatic, the rectangular one, and there's cylindrical one, which is the kind of form factor you would be most familiar with through using your TV remotes and other things. But prismatic cells are the ones typically found in your cell phones. What are modules? So these cells are then connected in series and parallel to get different configurations of voltages and uh, capacities, and uh, those combinations are called modules. And then you connect a bunch of modules in series to create a battery pack, and the battery pack is the end large bulky thing that you see in a vehicle. EV, if you've seen images of EV drivetrains, you'll see large bulky batteries over there. So when I say cell, I would mean these things, and when I say modules, I'll say mean these things. But and when I say batteries, I'll mean the end large big end product. But typically, I'll just use cells and batteries so that there's no confusion in between. So we had talked about a typical cell. Lithium-ion cells are no different. They have an anode, a cathode. There's an electrode material in between, and there are lithium ions that travel between the cathode and anode whenever we charge or discharge. So uh, now this is a very high level diagram of a lithium ion battery, but these batteries vary a lot, and there are a lot more components even inside a cell. There will be copper foil, there will be encasing, there will be binders, but we don't need to get into that detail at this point in time. But there are some high level ways in which lithium ion cells vary, and those can be important to know because they have very different performances and different economics as well as different geopolitical implications. So it would be good to know about them. So there are three ways in which cells can vary. There's a form factor. So you have this cylindrical cell and you have this prismatic cell. There's also something called a pouch cell, which is essentially a prismatic cell but without this metal encasing. Then cells can vary in size. There are some standard platforms of formats like 18650, which is essentially just an 18 mm diameter and 65 mm height, 2170, 4680. So these are, as we are moving forward, we are seeing larger and larger cylindrical cells because that means more packing efficiency and higher energy density. Packing efficiency is essentially the amount of total capacity you can pack into a given volume. So if you have larger cells, the spaces, interstitial spaces will be smaller, so you can pack more energy inside the same volume. And that is the reason we are moving towards 4680. And but again, it's harder to make larger cells because the possibility of something going wrong inside is higher. So we're still in the process. And the most important way in which cells differ is in the internal chemistry. So we talked about anode and cathode and electrolytes. So there are different variations of cathodes and different variations of anodes. Lithium ion is common, and lithium ion is the one that travels between the two electrodes, but these electrodes can have very different kinds of compositions. So there are a bunch of different chemistries like LCO, which is lithium cobalt oxide, LMO, manganese oxide, Lfp, NMC, NC, LTO. So these are all names that float around, and once you dig deeper, you will learn a bit more about them. Each of them has some pros and cons in terms of energy density, in terms of the power they can give, in terms of how long they last, in terms of uh, basically how many cycles they can give. But I don't want to confuse you with the too many terms, but I would like you to remember two terms, Lfp and Nmc, and I'll tell you why in a bit. But Lfp is essentially lithium ferrophosphate, so it contains lithium, iron, and phosphorus. Nmc is lithium, nickel, manganese, cobalt oxide, so it contains nickel, manganese, and cobalt. Typically, Lfp batteries are relatively lower powered but last longer. Nmc batteries are higher powered and but last for a shorter duration. And we'll talk a bit more about this in some time.